So we said that all the interesting software apps have a client piece and a cloud piece. We talked a little bit about the basics of the cloud piece. We'll have a lot more to say about the software structure of how that cloud piece is designed as we go into the next few lectures. But let's talk briefly about the client piece. Because to deploy software as a service, you've got a thing that runs on the cloud part and a thing that runs on the client part. And the client today is likely to be something you carry with you, maybe a smartphone that runs a mobile app of some kind. The Apple iPhone, I think, sort of redefined what a smartphone was, and today we think of it as the canonical smart device. And within just about 10 years of introducing it, more than 50% of traffic to sort of all websites was coming from mobile devices sort of like this. That's a huge deal for a device category that did not exist 10 years prior, where the only way to access the web before that was basically through a regular computer. Now, more traffic to websites is coming from mobile devices than coming from traditional computers or laptops. And by about 2020, we had reached about 50% smartphone penetration worldwide. That is remarkable. For a device that in 2007 didn't exist, by 2020, every other person in the world, on average, had one. Although I think it's because there are some people I see on BART who have 3 or 4, and then people who don't have any. But what this means is that as an app developer, this is the world you need to target. Maybe your app is not intended to be specifically a mobile app, but at the very least, it has to be mobile friendly, even if it's not mobile first. And so that means that you have to think about responsive design. Responsive design is, can you design a set of views of your app that do something sensible, whether they're being looked at on a large screen on a laptop or on a small screen on something like a smartphone? You have to think about accessibility. The class of users who have used these devices includes people who have various kinds of disabilities. They may have issues with vision. They may have issues with hearing. So you have to design parts of your app to the best of your ability so that the tools that people with disabilities use are able to work correctly when they're combined with your site. And you have to think about interactions. Interactions that are very natural when you have a keyboard become very awkward potentially if your keyboard is on a touch screen. Interactions that work on a touch screen where you're pointing at things might not actually work well if you have to do it with a mouse on a desktop. So as a designer, you really have to think somewhat about the interaction model in a much broader way than in 2007 when you knew you were designing for a laptop, because that's kind of all there was. So what are the technologies that can sort of help us in this direction? What are the tools that we can use? And to answer this, let me preface this by saying there's a reason that this course is Intro to Software Engineering. The hardest thing about writing the lectures in the book for this course is figuring out which 10% of each topic to cover so that you know what you don't know, so that you know where you need more depth in the future. And to me, this is one of those areas, is thinking about interaction design. So we'll start with HTML, which is the lingua franca, I suppose, of the web. The idea is very simple. We have some text that we would like to put up somewhere, but that text actually has some logical structure, like it's got things that are headings, things that are divided into paragraphs, things that are more like a bullet list. And by combining what's called the markup, the tags that surround the text, and we have a program that can combine those things and actually render the result, then we get something that looks a little bit nicer, right? It's basically, at bottom, HTML is a way of describing the structure of a collection of text and other media, right? It's not really about visual appearance. We'll get to that separately. So there's a whole bunch you can learn about HTML. Some of you may already have sort of learned some of it by osmosis. There are some resources that we recommend in the very first chapter of the book on if you don't have some experience with HTML, here is where you can go learn the 20% of HTML that will give you 80% of the value that you need as a developer. But in a nutshell, here's how it works. A document in HTML is a hierarchy of elements. There are a few different sort of categories of elements. Some of them are elements for rendering text, like headings, lists, tables, and paragraphs. Some of them are other kinds of objects, like images or chunks of JavaScript that do something whizzy and make a little guy pop out of the page. Some of them are forms that allow you to collect input from the user. They can type text, they can check radio buttons and check buttons, they can choose items from menus. The elements in HTML, you've probably all seen some bit of it, are delimited by these angle brackets. Some of the elements have attributes. For example, here's a paragraph that has a class attribute whose value in this case is strong. Some elements can be nested inside of other elements. There's a whole set of rules about which things are allowed to be nested inside which other things. But for example, a very generic element called a div has no visual counterpart. It only serves to indicate logical structure. And here's an example of a paragraph element embedded inside of a div. By the way, if anybody was ever curious about why they chose angle brackets for this, it's because HTML actually derives from a much older language called Standard Generalized Markup Language, SGML, which dates from the 1960s and was developed by IBM for exactly this purpose, to essentially put metadata into big text documents so that they could be machine searched and machine indexed. So don't tell me legacy code isn't important. We're going to come back to that topic too. HTML tells you about the structure of a document. It's not supposed to tell you how the document visually looks. For that, we use cascading style sheets. And one of the very first things you'll see in most HTML pages is a link that associates some particular style sheet with this HTML page. The style sheet is basically a set of rules that describes how different elements on that page should be visually rendered. It speaks to things like font colors, placements, how things wrap around each other if they don't fit on the page. Almost any imaginable aspect of the visual appearance is controlled ultimately, or should be, through CSS. Of the many possible attributes that HTML elements can have, two of them that are particularly important for CSS, and this is in the category of life skill, are the ID and class attributes of an element. The ID of any element has to be unique within the page. The class can be attached to many different elements on the page, even different types of elements. So for example, here we have a div with a specific ID. It's also got this class. No other element on the page may have the same ID. Many other elements on the page could have the same class. And basically the reason we do this is not the only way to attach styling information to elements, but it is one of the most efficient and convenient ways. So if there's a particular element on the page that needs to be singled out for something, you can refer to it by its unique ID. But if there's a group of elements and you want to apply some common styling or some common behaviors to those groups of elements, you might attach the same class or classes to the elements and refer to them that way. And much later, when we talk about JavaScript and the different ways that JavaScript can manipulate the contents of an HTML document, the same thing will apply. That the way we identify parts of the page we want to operate on can be based on things like class and ID. So the goal is that the HTML part of your page should only show the structure. Everything associated with visual styling is exclusively in CSS. CSS selectors are a life skill. When I say life skill, those are loaded words. But I mean, if you're a software engineer, there's a few things you're going to just come up, like no matter which language or framework you learn, this is one of them. Regular expressions are another, but we'll get to those later. I know everybody loves regular expressions. But here's a little snippet of HTML that has some attributes with class or some elements with class and ID attributes attached to them. How could we refer to these for CSS? Well, we could say all of the elements that have a particular kind of tag. So an H1 element, this would refer only to what's between the H1 tags here. We could refer to things by the class names. So any element, no matter what type it is, as long as it has a class container, that's what we use the dot for. The element's unique ID, that's what we use the hash sign for. A combination of both. So only div elements that have the class container should be affected. Or we could use a descendant relationship. We want to affect any element that has this class, but only if it occurs inside of some div. So kind of a parent-child nesting. And if you don't say anything about an element, the browser has sort of a baseline set of rules that it uses. And the total set of rules for when there's multiple ways to reference an element and you've got different rules that could match the same time and which one wins, you don't want to read that. It's extremely confusing. But if you look inside a CSS file, what you will see is a set of selectors basically saying, if the element matches this, so if it's a body element, or if it's a element that has the class validation error, there's a whole bunch of styling rules that you can apply that talk about where you put it, positioning, fonts, colors, anything you can imagine. If you're like me and you try to do this yourself, you will come up with something that looks like it was probably designed by malicious vandals. So what most of you should probably do is use a framework where people who have taste and training in this and who do CSS well have actually come up with a set of elements and sort of higher level elements that you can use in a tasteful manner that also have other advantages. My favorite framework for this is Bootstrap. It's an open source framework that actually came out of Twitter originally. And I think of it as a mobile first framework because it's particularly well suited to building apps that will have primarily a mobile interface, but it also extends quite well when that user interface is used on larger or sort of non-mobile devices, because one of the big features you get is a set of elements that can be used in what's called a responsive layout. That means a layout that does something sensible even across a pretty wide range of screen sizes. one of the ways it does this is rather than just sort of having you use low-level HTML elements like lists and text boxes, it actually provides these higher-level elements that are collections of HTML elements already made for you. Those higher-level components can actually be used as components on a page. This is an example of a responsive template that I got off of the Bootstrap website somewhere. And the thing to notice is if I try to resize this window, notice a few things that happen as I start to make the window narrower. At some point, it's not wide enough to gracefully show the 3 different cards, and the layout will suddenly switch so that the cards are stacked in a different way. You'll notice that the menu also moved from being at the far right-hand side to being in the center. And if I continue to shrink it to simulate something like a smartphone, sooner or later I'll get to a single design. The menu has changed again. You can see that the formatting has changed again. The formatting at the bottom of the page also is dependent on the screen size. And if you look at the HTML that underlies this, there's nothing dynamic in there. There's no JavaScript or anything else going on. This is all done purely using CSS, which should tell you 2 things. One of them is, wow, CSS is really powerful if you can describe all of this without writing actual imperative code. The second one is, unless you're really, really good at CSS, you shouldn't try to do this yourself. These elements that show the 3 different pricing tiers is what they call a card in Bootstrap. A card can have a title. It can have sort of a featured text. It can have body text. You can embed other elements in it. You see that the buttons have different ways of highlighting. All of this stuff is built into the framework. And another benefit of doing that is that those elements and components are designed with some built-in support for accessibility, meaning that, for example, someone who is using a screen reader to help them render this web page, that element is going to have information embedded in it that is friendly to and helps support the operation of some of those tools. We will have a lot more to say about that when we talk about user interfaces and accessibility as well. So there's a lot of reasons to use a framework. You get a better design. You get accessibility features that you would otherwise have to put in yourself. And if you go to getbootstrap.com, they have a whole bunch of demos. There's stuff you can download. But as a first order, if you're designing a prototype for a site, I sort of think you needed a good reason not to begin from a good framework because a lot of this work has already been done for you. And by the way, it is pretty well integrated into Rails. So as we start doing Rails apps, this is now sort of part of the way that the user interface part of those apps is designed to work. And how are we actually going to build those mobile apps? There's a number of ways to do this, but I think the way that we're going to focus on in this class is what's come to be called a progressive web app, or PWA. PWA basically means you're building your app using HTML and CSS and JavaScript. You're essentially building it the same way that you would build a mobile responsive site, but there's a few additional things that you can do that essentially package the app in such a way that it can be downloaded. You could distribute it through an app store, but more importantly, it can also operate offline. It can work when it is not connected to the internet. And a plain old website by default will not do that, right? If you try to interact with a website when you're not connected, you'll usually just get an error page. But there is now a set of mechanisms that will allow you to write a plain old web page-based app that will actually do something sensible in the absence of a network connection. Now, of course, there's also frameworks that allow you to, write that HTML, CSS, JavaScript app, and then essentially wrap it in a container that makes it look like a native app. And you can certainly use those. They have a little bit more of a learning curve. But unlike a progressive web app, now you've got an app that has to be manually downloaded each time there's an update. Whereas a progressive web app, because it's really backed by a regular old website, you can essentially update it transparently and in place without the user having to sort of do an app update on their phone. You could also write a native app. You can use React Native. You can use the iOS development environment directly. But really, I think in my view, the reason to do that is that you need a level of performance or a level of hardware feature access that simply is not available through JavaScript bindings. The JavaScript bindings for what you can do on mobile browsers are getting better all the time. And if you are able to design your app as an HTML, CSS, JavaScript app, not only do you sort of get all the benefits of you don't have to manually install it, you don't have to manually update it, but more importantly, as a developer, you get to use really good tools to develop it. You get to use one set of tools to develop your plain old website, your mobile app, your Apple Watch app, and the development and debugging tools in that environment are really getting better all the time because it is what everybody uses. So there's material in the textbook, and we'll have some material when we talk about mobile app packaging on how to package things as a progressive web app. It's one of the interesting uses of JavaScript. But I think the good news is we now live in a world where you can deploy your app to the cloud. You can pay only for the capacity that your users actually use. And you can author your app using the same technologies as you would have been using to author a plain old user-facing laptop-based web app just a few years ago. And life will be really, really good.